Hello, my name is Chris Applegate, and I am part of the Customer Solution Center based here in Round Rock, Texas. And I'm going to walk through a Hortonworks 2.4 installation on some Dell PowerEdge R730XDs. Some of the stuff that's outside the scope of this demonstration is the actual bare metal provisioning, how you got that up, how you set up the network. I'll touch on it just a little bit, but we're not going to cover specifically some of that work that's been done. So let's go ahead and just dive right in. So what you see on the screen is my Foreman installation. This is the tool that I choose to use to do all of my provisioning. It's a free open source tool. I'm a big fan of it. What you can see here is 16 nodes that have already been built. One of them is the Foreman virtual machine itself, so we take that out. And then the other 15 are what we're going to be working with. That's 5 infrastructure nodes that are actually Dell PowerEdge R630s, and then 10 R730XDs that are going to serve as my data nodes. You can see the host names here have the role of the server, and then the numbers are actually the last octet of the IP address of their DRAC card. So they can instantly see this is the example. Data 10 is actually the 10th server in that rack, and if I use 172.16.1.10, I can go into the DRAC of that host. So we use that as kind of a kernel to distinguish servers. I've built host groups in Foreman for my infrastructure nodes and my data nodes. Most likely in practice you would see a different profile for your edge nodes, a different profile for your HA node, different profile for your name nodes. In here I kind of treat them, all the infrastructure nodes as one type and all the data nodes as another. You can see my partition tables for my data nodes. This will tell you how we set up the drives. So here in the screen you can see, other than the boot partition, right, and the root volume that goes on the FlexBay drives. Now these are actually the 16 drive R730XD, where you have the 4 drive mid bay. The way that it enumerates the drives, and this is something you just have to really learn by experience, is it does the 12 drives up front first, then it does the 2 drives in the FlexBay, and then it does the 4 drives in the mid bay. So I've adjusted my partitioning to reflect that, where the top section up here that goes over the OS is actually being done to SDQ, right? So that's the FlexBay drives, and then I start my data drive starting at A through L, and then I pick it up at M, N, O, P for the rest of my data drives. Now in this particular configuration, A and B, SD A and B, with the first 2 drives, are actually solid state drives, and I'm going to be using one of the solid state drives for Spark Scratch and one of the solid state drives for tiering inside HDFS. So with all that said, let's go ahead and check out all my hosts here, and then we'll go ahead and we'll drop into the command line. And let me see if I can make that any bigger. Let's see. Doesn't look like I'm able to do that here. Maybe. Give me 1 second. Yeah, it doesn't look like that's going to work, so just watch carefully if you can, and then you can meet with us offline if you want to go over any of the specific things that we did here. So a couple of, I'm going to tour around the environment just real quick. So if I go into one of the data nodes, I'm going to SSH from my Foreman machine into one of the data nodes. So I'm going to say data 6, and I do a mount. You can see everybody's mounted here as that drive partition dictated, SDA all the way through. And most importantly, if I go and do a drive free, you can see that the capacities, those are my 800 gig SSDs, right, mounted as 1 and 2. Now, it's a really good idea to make sure that this has been done on every node exactly the same way, that all your drives are enumerated in the same order, and when you refer to data 1 and data 2, they refer to the SSD drives. So what I'm actually going to do is I'm going to use another tool. I'm going to drop out to my Foreman server, and then we use a tool called Cluster Shell to send commands to all the nodes at once. right? And so we can send the same command to all the nodes. And what I'm actually going to do is I'm going to send it to just the data nodes. So I'm going to say to the group data nodes, sending the command drive free -h, right? So the command I just ran up here. And then I'm going to pipe that into looking for the phrase 734. So what that's going to do is that's going to pull out of this list these two lines here that have 734 gigs in them, right? Change that to grep. Then the next thing I'm going to do is I'm going to pass it through word count to show me the number of lines. So what I should get here, if everything is set up correctly, is it parsing through and identifying 2 drives out of DF that are my 2 SSD drives. So I can make sure everybody sees those SSD drives and they're mounted in the same way. Right? There we go. So I know it's hard to read that blue text, but that's every one of the host names in my data nodes, and it's got everybody shows that they see 2 lines that look just like that. Right? So that's a pretty good indicator that things are set up correctly. Right, and I can do the same thing to count the total number of drives. If I grep for the word data, right, this should show me the same number, 16 data drives for everybody. That's exactly what I'm expecting. Right. All right, so now what I'm going to do is I'm going to go ahead and I'm going to install Ambari Manager on the first name node server. Actually, you know what, before I do that, there's a couple of other things I have to do. So what you're seeing here is my script for turning on some of the typical features that we use here. Things like turning off transparent huge pages, swappiness, etc. Some of these don't apply because this is Rel 7. I'm actually running on Rel 7.2, build 1511. And so some of those things only apply on Rel 6, but what I'm going to do is I'm going to take all this stuff and you'll see I'm going to run it against every host. Another important thing that happens here is a script I wrote to bond the network interfaces. Right? So I'm running those commands. You see the transparent huge page, that's not something that exists inside Rel 7, so it ignored that command. It's doing an NTP sync, right? And now it's bonding the network services, right? So if all goes as planned here, I'll be able to exit out of this command and then issue a host name against every host, and they should all respond now on their new 20 gig bonded interfaces. Right, so here we go. Clush, which is the command, the cluster shell to everybody, sending the command host name. There we go. Everybody came back. That means everybody's network successfully came back up. All right, I can also do a IPA grep for bond 0 on everybody, and everybody's got it. Right, I see my 2 slaves for each one as well as the bond itself. All right, let's go in and start installing. I'm going to SSH into name1. All right, then from the Hortonworks website, I've just gone out and pasted the link to their yum repo for Ambari. So I go back to the name server, I paste that in, goes out there, fetches that repo, and then I issue the command yum install Ambari server. Right, so it's going to go out there, fetch the latest version of Ambari, and install it. It also grabs Postgres, the database, and installs that using the default settings as well. Right, so this just downloads the packages. It doesn't set up Ambari, it doesn't start Ambari or anything like that. We're going to do that next. All right, so now I issue the command Ambari server setup. Now it's gone ahead and checked that SE Linux is disabled, which is something that I did via my Foreman installation script. That's a really, really important thing. I would recommend keeping it that way unless you have some significant security concerns. Right? We're not going to do any custom installation steps. We're going to accept this. Now the one thing that I'm going to do here that's a little atypical is for other reasons, for my own selfish motives, I'm going to use the Oracle 1.7 JDK because I'm going to be using some software later on that requires 1.7 and not 1.8. So I hit number 2 there. It's saying, do you agree to the license? Yes. And now it's downloading the JDK and it'll install that. I'm sure eventually the particular tool that I'm going to be using will start supporting 1.8 and this will become a moot point, but for now I know for a fact it's still 1.7 only. Alright, do we need to do any advanced database configuration? For this installation and for this test, I'm not going to do that. Nothing advanced, no moving any partitions around or creating any special users. Alright, so it's actually standing up the Postgres database, getting it set up for Ambari. Right, remember Ambari is just like the Cloudera Manager. Right, but it's the Hortonworks flavor of that. Alright, setup is done. Now I'm going to issue the command Ambari server start. It's running in the background. Another important thing that I've done prior to this is I've turned the firewall off on that host. Otherwise, when I go to hit the website here in a second, it's not going to show like it actually works. So it's a little bit different in 7. It's called Firewall D instead of IP tables. Alright, so now if I go out here and I hit my name1 server, look at that, Ambari. Log in with the default admin. Alright, now I'm ready to create my first new cluster. Launch my install wizard and create a cluster called POC. I'm going to use the latest version of Hortonworks, HTTP 2.4. Alright, now I'm going to install the range, specify the specific range of hosts. So I have name 1 through 2.poc.local, ha3.poc.local, edge 4.poc.local, HDF, Hortonworks Data Flow 5.poc.local, and then data 6 through 15.poc.local. Alright, now I need to specify the SSH key that I've already pre-installed on every host. So I go out here and I grab the SSH key, paste it in. Now it's going to go out and install the Ambari agent on all those hosts. It confirms with me all those hosts. Yep, that looks good. Now there, and we wait for it to actually do the install. Couple of things that I've seen here go wrong. One I was just working with a colleague on the other day is you'll have been able to ping everything. You'll have been able to do most of the stuff that you've already seen me do correctly, but here, when it's actually trying to do a binary install and it's going out and fetching large packages, it will actually fail. And what that turns out, what that was jumbo frames were not enabled on the switch that it was plugged into, but it was enabled on the bond. So the bond thought it could do jumbo frames, but the switch couldn't do jumbo frames. And so anytime you had a packet over 9,000, over 1,500 MTU, which is the jumbo frame designator, that package would fail, but pings and all that other stuff that are under 1,500 will work just fine. So it's really, really hard to troubleshoot because it looked like sometimes when I talk to it, it works. Sometimes when I talk to it, it doesn't work. But check your jumbo frames. Also, if you're doing any additional tagging or anything like that, that might add some payload size to that jumbo frame. So be aware of that. We've seen setting over 9,000 MTU fix a lot of problems, especially in VMware environments. Alright, so I'm not going to install everything under the sun, so I'm going to uncheck everybody. I'm going to do HDFS, I'm going to do Yarn and MapReduce. It'll actually require me, only because I've done this a couple of times, it's going to require TES. I want Hive and HBase and Pig. I don't need Scoop for now. I'm going to use Uzi, Zookeeper. I'm not going to use Falcon, Storm, Flume, Accumulo. I do want Ambari Metrics, that's how they do their dashboards. Don't need an Atlas, Kafka, Nox, Mahout, Slider, Smart Sense, it's nice to have, and then Spark. All right, now we're going to do role assignments. This is almost a religious discussion as to what should go where. All right, so please check with your solution architects and your sales specialists to figure out exactly what your config should be. I'm going to go with mine, right? So my secondary name node is name 2. My primary node is name 1. Most of my services are getting sent to name 1, right? With a couple of exceptions. Right? Name 1 by far gets the vast majority of services. Zookeeper, I split between name 1, name 2, and HA3, right? Because it needs 3 hosts to be able to do tie breaking for HA. Metrics collector going to name 1. Smart Sense, that's that Hortonworks metrics gathering tool, and Grafana are going there. Spark history server we're going to put on name 1 as well. So that's it, really. Name 2 is getting a little bit, HA3 is getting just 1 role, but name 1 gets the vast majority of all master roles. All right, now this is a list you really need to double check every time, because you'll see that it actually just tried to make my edge node and my HDF nodes data nodes. That's not good. All right, so I'm going to go ahead and uncheck those. I am going to be playing with Phoenix, so I'm going to add a Phoenix query server role to my name 1 server. Right, and then something I like to do is I like to make every host a client. Personal preference. All right, but I like the client binaries and client XMLs on every host. All right, this is where things start to get pretty important. And the very first thing I'm going to do is I'm going to pull out data 1. Right? He's not going to be a data volume. Remember, my 2 SSDs are data 1 and data 2. Right, so data 1 goes bye-bye. Another thing is at the very bottom of the list. Sometimes it adds in var. Don't want that. Right? All right, so now we have 1 SSD and the spinning disks. The other thing I'm going to do is I'm going to now move my name node directory over to data 1. Right? That's because I'm using this for Spark Scratch Space, and we actually use those name node directories for not just name node lookups, but also for Spark Scratch Space in Yarn. All right, so the other thing is, since I am going to be doing tiering here, I need to classify each of my directories as a particular type of storage. So SSD on the first one, and then everybody else is disk. You can actually go ahead and disk is one of the assumed defaults, but if you decide to ever use anything more than SSD and disk, you'd have to come in here and relabel anything everything anyway. So I go ahead and just do it now. Save myself some time later, potentially. All right. So we have one classified as SSD, everybody else classified as disk, and then once everything comes up, I'll do the storage policy setting for tiering. That's pretty much everything I need to do in here. Now I come over to Yarn, and I'm going to drop that memory down to 128. All right. Go to Hive, and I'm going to go in here to advanced. You see how all these red marks here? That means there's something here that you have to set. Most often, it's just a password you're going to have to type in. You have to set a password. I'm using the word password. You see, as soon as I type that in, it goes away. Uzi, same thing, needs a password. Alright, that should be everything. Alright, a couple of warnings here. I'm going to do tuning after the fact and adjusting all these sizes, but this is enough to get things started. So I'm going to proceed anyway. Yeah, don't use Derby in production. Again, when you're hardening this and moving this in towards production, you'll be having a much more detailed conversation with your consultants and your solution architects. All right, let's go ahead and deploy it. I'm going to throw a caveat out here that I have still seen this next step where it will issue warnings on a number of nodes due to some services not starting immediately. So I fully anticipate that that could happen in our install here. If we get any red, then I'll most likely hit retry. If I just get warnings, I'll most likely work through it and do services restarts after I come out of the Ambari installer. I'm going to go ahead and pause the video here while this finishes because this can take some time, right? So I will see you back in a second. All right, back, and in a less than stunning turn of events, we do have the warnings encountered as would be expected, as I've seen typically over the last couple of installs, but that's okay because we will go ahead and resolve those shortly. Right, so we say next, and we've completed our Ambari install, and now it's going to actually take us into Ambari itself. We'll probably have to do some service restarts just to clean up everything. Right, you can see there Hive and HBase are the two offenders. Let's go ahead and go in and restart Hive. This looks like it's specifically the web HCAT role that failed. Look at that. Same thing on HBase. Looks like it's the HBase master. Oh, I guess I'm on, yeah, alright. So yeah, Hive and then HBase, that's right. And give it a second, and we should see that red X, or that red 1, go away once all the metrics get updated. Sometimes it can take a second or two. Alright, what I'm going to do here is I'm actually going to go ahead and check to make sure that tiering has been recognized. So I go into the name node UI, shows me everything in here, shows me my total amount of space, my number of live nodes, all that lovely stuff, but where I really want to see is this right here. Alright, it's recognized my disk and SSD tagged volumes and their approximate storage capacity. You can see both of them are effectively unused, other than a little bit of metadata. Alright, so there the red number 1 went away. So now we've got to go do a couple of things to enable tiering. Alright, so first things first, I'm going to go into name 1, and I am going to, so that I can use root, I'm going to create a home directory for root. So I sudo as the user hdfs, and then I run hadoop fs, and then I'm going to do a make directory /user/root. Alright, and then I'm going to change the owner of that directory to root, and now I'll be able to issue commands as root. Right? So what I'm actually going to do is create a directory, so hadoop fs mkdir, and I'm going to create a couple directories. Under user root, I'm going to create one called SSD. Actually, yeah, I'm going to create, one called SSD. One called 1 spelled out SSD, and one called disk. All right. Now, as my master HDFS user, I'm going to go ahead and run HDFS, and it's, I believe, -list storage policies when you spell storage right. Sometimes we just need help. All right. I always have to look up the exact syntax of the command. HDFS storage policies. All right, so and then we do a list policies. All right, it's going to show us the default storage policies. Right, and so cold means I'm going to store everything on replica. Warm means I'm going to store a little bit on disk and a little bit on archive. I'm sorry, cold meant to store a little on archive. Warm is one on disk, one on archive. Hot is everything on disk. That's actually the default, right? And there's some replication failbacks there. One SSD means you have one replica on SSD, the remaining on disk. All SSD means that you have everything, all replicas sitting on SSD. And lazy persist is actually for your RAM disk with a disk backup. All right, so what I'm actually going to do is we created 3 directories. I'm going to do on disk, I'm going to use hot. On SSD, I'm going to use all SSD. And on the one SSD, I'm going to use one SSD. So to do a storage policy, I do set storage policy. And I use the path that I'm going to use, which is /user/root/SSD. Right, and I'm going to use the policy called all SSD. Done. Now I do the same thing for one SSD to my one SSD folder. And I do policy warm to my disk folder. I don't have to do this because, again, warm is the default policy, but I want to show everybody the tagging. All right, there we go. And then if I want to get the storage policy, just to validate that everything is done correctly, get storage policy. Hey, look at that, warm is set. All right, so Chris knows what he's doing. And now, anytime you write into one of those directories, it's going to use that storage policy. Now, as you know, with tiering, you would have to mark storage policies, or sorry, mark directories and tag them with a new storage policy in order to have any type of data progression happen. Right? So you can issue the mover command, which will go and enforce any policy changes. Right? But those are all manual events that you'd have to do. Right? You could script some of that to help do data progression down the tiers, but it's very much a manual task to do any type of tiering. So in this case, I would want to probably the bulk of my standard operations I'm going to do into disk. Then some of my higher priorities I might do on the one SSD, and then some of my really critical speed sensitive stuff I might do to that folder called all SSD. Right. All right, so that's a very quick, fast install of Hortonworks 2.4, HDP 2.4 on Dell PowerEdge servers. So if you have any other further questions or want to go through anything else, please contact your sales specialists or somebody at the Customer Solution Center. All right, thank you very much.